This is explanation video of experiment 8, self-organizing maps. The aim is to develop a clustering model using self-organizing maps, evaluate its performance, and visualize the results using Power BI. The first question is to import libraries and load dataset using pandas data frame from the CSV file winefcm.csv. And the second question is missing value imputation. Real world datasets often contain missing values. To handle this, we replace missing value with the mean of each column. This ensures that the dataset remains complete without introducing bias. The third question is standardization. Clustering algorithms are sensitive to feature scales. We use a standard scaler to transform the data so that each feature has mean 0 and standard deviation 1. This ensures that all features contribute equally to the clustering process. The third question is standardization. Clustering algorithms are sensitive to scales. We use standard scaler to transform the data so that each feature has mean 0 and standard deviation 1. And the fourth question is initialization of SOM parameters. SOM requires setting important parameters such as learning rate, sigma, number of iteration, initial weight, etc. These parameters influence how the SOM learns patterns in the data. And the fifth question is visualizing input data. Before applying clusters, we visualize the data using scatter plot of two features. This gives an idea of how the data is distributed and whether clusters may exist. The sixth question is SOM clustering with multiple cluster size. We apply SOM clustering by looping through different cluster sizes 2 to 5. For each value, the sum SOM model is initialized. The model is trained using input data. Each data point is mapped to a neuron. Cluster labels are assigned based on neuron positions. When they calculate the silhouette score for each clustering result. This is the question, and the seventh question is silhouette score curve. We plot the silhouette score against the number of clusters. This graph helps us identify the optimal number of clusters where the score is highest. The eighth question is performance evaluation. We evaluate a clustering using silhouette score, partition coefficient, partition entropy. The ninth question is best model selection. We select the model with the highest silhouette score, which indicates the best cluster structure for the dataset. Um, and the tenth question is display cluster centroids. In SOM, centroids are represented by neuron weights. These weights indicate the central pattern of each cluster. The 11th question is cluster visualization. We plot cluster using scatter plot and assign different colors to each cluster. This helps distinguish between the different groups. The 12th question is Power BI visualization. Finally, we export the dataset with the cluster levels and use Power BI to create dashboards. Charts such as bar graph and scatter plots are used to analyze cluster distribution and feature behavior. uh, Final understanding. SOM is an unsupervised neural network used for clustering and visualization. It maps high dimensional data into a lower dimensional space while preserving relationships, making it useful for pattern recognition.